In this video, we're going to learn how to apply implicit differentiation to find the equation of a tangent at a particular point. The question I have over here says that a curve has the equation x cubed minus x squared y minus y cubed is equal to 3, and I need to find the equation of the tangent at the point 2, 1. We know a tangent is a straight line, and to find the equation of a straight line, the formula is y minus y1 is equal to m times x minus x1. In order to use this formula, we need to know two things. The first thing is to know a point on a line, and I know a point on this tangent which is 2, 1. So this is going to be x1 and this is going to be y1. The other thing that I need to know in order to use this formula is m. M is the gradient. And to find the gradient, there are a couple of methods. The first is to use the formula of rise upon run. But in order to use that formula, I need to know 2 points on a line. Over here, I only have a single point on this tangent. So the other method would be to find the gradient function. And after finding the gradient function, if I plug in these coordinates in that gradient function, I'll get the gradient of the tangent at this point. So let's find the gradient function of this equation. We know this is an implicit equation because it's all tangled up in x's and y's, and I cannot make any one particular variable a subject. So I'll need to differentiate this implicitly. And to differentiate this implicitly, the first step would be to differentiate both sides with respect to x. So I'm going to take the derivative of the left hand side with respect to x, which is x cubed minus x squared y minus y cubed equals to the derivative of 3 with respect to x. Now when I'm taking the derivative of the left hand side with respect to x, I'll need to differentiate each term separately. The derivative of x cubed, using the power rule, the power comes down, so it's going to be 3x and the power gets reduced by 1, so 3x squared. Now for the derivative of this x squared y, here two separate functions are a product of each other. And whenever we have such a case, we use the product rule. So I name this function as u and this as v. And the derivative of this is going to be, the product rule says, u times v prime plus v times u prime. So here the derivative is going to be u, which is x squared, so x squared times v prime, which is dy upon dx. This is the derivative of y with respect to x, plus v, which is y, and plus u prime, the derivative of x squared with respect to x is 2x. So this is the derivative. If I plug in over here, I'll get minus times x squared dy upon dx, and then plus 2x times y is 2xy, minus the derivative of y cubed with respect to x is going to be 3y squared, and whenever we differentiate terms of y, we multiply the derivative by dy upon dx, equals to the derivative of 3 with respect to x. 3 is a constant, so its derivative is going to be 0. So this is the derivative. Now all there is left is to simplify this and make dy upon dx the subject. If I simplify the left hand side, I am going to get 3x squared minus x squared dy upon dx minus 2xy minus 3y squared dy upon dx equals to 0. Subtracting both sides of the equation by non-dy upon dx terms and sending them on the other side would give me minus x squared dy upon dx minus 3y squared dy upon dx equals to minus 3x squared plus 2xy. Factoring out dy upon dx on the left hand side would give me dy upon dx times minus x squared minus 3y squared equals to minus 3x squared plus 2xy. And dividing both sides by this term would give me dy upon dx equals to minus 3x squared plus 2xy divided by minus x squared minus 3y squared. So this is my gradient function of this equation. Next, for the gradient at the point 2, 1, I'll plug in these coordinates in this gradient function. So dy upon dx is going to be equal to minus 3 times x, the x coordinate is 2, so minus 3 times 2 squared, plus 2 times x, x is 2, and times y, which is 1, divided by minus x squared, so minus times 2 squared, minus 3 times y squared, the y coordinate is 1, so minus 3 times 1 squared. And if I put all of this in the calculator, the value that I get is equal to 8 upon 7. So this is the gradient of the tangent at this point 2, 1. Now I know both the point on the line, which I already had, and the gradient of the line, which I have calculated to be 8 upon 7. So now I'm going to find the equation of the tangent by using this formula here. Y minus y1 is equal to m times x minus x1. The y coordinate is 1, so y minus 1 equals to m. The gradient is 8 upon 7. So 8 upon 7 times x minus x1. The x coordinate is 2. Simplifying the right hand side would give me y minus 1 equals to 8 upon 7x minus 8 upon 7 times 2 is minus 16 upon 7. And now adding 1 on both sides would give me y is equal to 8 upon 7x minus 16 upon 7 plus 1. Minus 16 upon 7 plus 1 is equal to minus 9 upon 7. So I can say that the equation is y is equal to 8 upon 7x minus 9 upon 7. This is the equation of the tangent at the point 2, 1. This is my answer.